Hi, welcome to the Introduction to Computer Vision. I'm Professor Aaron Bobick here at Georgia Tech. I'm thrilled to be able to teach this course in this medium. I've been teaching this for quite a while. I've been a professor for, oh my gosh, almost 25 years in computer vision. Spent some time at the MIT Media Lab, and I've been at Georgia Tech for the last 15 years. My own research has been predominantly in activity recognition, and now it's moved a little bit more to robotics in terms of vision for robots understanding people. But the basics of this course is to cover sort of the fundamentals of computer vision, to give you a background enough that you could, just enough to be dangerous. So before we tell you more about the course, it's important that you meet a couple of other people who are responsible for the success of this course. And it will be a success, or I'll be really, really annoyed, and then people see, everybody's going to see this and they'll think really poorly of me. Anyway, the first person you have to meet is probably the most important person in making this a success, no pressure, is Dr. Arpan Chakravarty, who is our course developer. Come on over, Arpan. So tell the good folks at home or sitting at their desks at work a little something about yourself.
Sure. I got my PhD from North Carolina State University in biologically inspired computer vision.
What is that?
You take human vision systems and animal vision systems, study them, how they function, and use those ideas in an artificial setting.
Cool. And what made you want to do this course development work?
Well, I heard that Udacity is making this online computer vision course with Georgia Tech, and I thought this is a good way to use the knowledge I've put together over the years.
Okay, great. Well, thanks. And you guys will be hearing more from Arpan as the time goes on. So the other really important person you have to meet is Megan Smith. Megan is our video guru. She is the film person, the editing person, the production person. She makes my hair look non-existent, and just makes everything look great. She also allows me to illustrate the difference between the illusion of power and actual power. See, the illusion of power is I can call Megan over, and she'll probably come over and say hello. Megan, come on over and say hello. Say hello to everybody.
Hello.
The reason I say that that's the illusion of power, the person who has the real power is Megan, because she does the video editing. So if she wanted to, she could make me look incredibly foolish. But you would never do that, would you?
Never.
Uh-huh. Okay, well, you'll be hearing from her sometimes when we ask some questions, and she makes some interesting noises in the background. But I just wanted you to put a face with the beautiful melodic voice that you'll be hearing later. So thanks, Megan. All right, so that's the crew, and I think this is going to be a good time. I mean, it's maybe that's a little bit much. I think you'll enjoy the class. There is a lot to be learned. We can't actually cover all of computer vision, but we can sort of go over a whole bunch of the fundamentals, and I think you'll learn a lot if you actually do the work. And it is a bunch of work. I don't want to pretend otherwise, but if you do it, I think you'll come away with the ability to do things that you couldn't do before. All right, so let's begin our trip down computer vision lane here. So the first question you might ask is, what is computer vision?
What is computer vision?
See, I told you were going to hear from Megan. Well, there's a couple of ways of thinking about it. I like this slide that I borrowed from Steve Seitz, where he talks about every picture tells a story. And one way of thinking about computer vision is the goal of computer vision is to interpret images. That is, say something about what's present in the scene or what's actually going on. So what we're doing is we're going to take images in, and what's going to come out is something that has some meaning to it. That is, we're going to create some sort of interpretation, some sort of an understanding of what that image is representative of. This is different. Many of you may have some exposure to image processing, which is the manipulation of images. That's images in and images out. And we'll talk a little bit about that because you use image processing for computer vision. But fundamentally, computer vision is about understanding something that's in the image. So as a thought experiment, and actually as one of these Arpan quizzes, that's what we're going to call these things, Arpan quizzes. Here's the scene. So I want you to just take a look at that scene, and then you can stare at it as long as you want. Okay, you got it? And here's what I want you to do. Type in the little text box there as many items that you could label or identify as you want. Make sure when you do, you type it with a comma-separated list. That way the machine can understand what's going on. So here you can see a list of items that were put in by somebody not all that imaginative. No, it wasn't Arpan, it was somebody else, really. You know, sofa, table, chair, things that were in the room. But notice those are specific things. You could have said wall, floor. You might have said that's a living room. That's probably a house. That's a modern house. Or you could have said that's the house of an upper middle class family taken back in 1997 somewhere near Ohio. How you would know that, I don't know, but maybe you know something about interior decorating. That was cool. Picture, tell me what's in the picture. But those labels, you notice, those were all about sort of static objects that were present in a single image. These days, especially with sort of the ubiquity of media, computer vision is not limited to just processing a single image. In fact, we can process a whole bunch of images, such as a video. And video allows us to start talking about things like action. So to illustrate that, let's call back on Arpan again. Arpan, come on over. All right, Arpan, do your thing. So here's a quick quiz. What did Arpan just do? Well, what Arpan just did is he flapped his arms like a bird. Not such a great bird, but a bird, okay? And the question you might ask is, how would I get a computer to do that?
How would I get a computer to do that?
Well, the good news is, at the very end of this class, we'll give you at least a few ways that you could actually think about a computer processing video that would be able to recognize simple actions done by a person. If that's what computer vision is, why would you want to study this? Well, I mean, A, you might want to get a Master's of Computer Science degree at Georgia Tech and everything else was filled. And you got stuck with Bobick. Well, okay, so here you are. But there's actually some really good reasons to do that. These days, images and imagery have become ubiquitous in all of our technology. Cameras, video, you can stream them, you can send them, etc. So what's become fundamental to an awful lot of systems is the manipulation and the processing of imagery and extracting information from that. There are domains such as surveillance, or building 3D models from medical imaging, or capturing for motion capture. These are all different current industries that leverage computer vision in a variety of ways. But most of all, the reason to do it is just a really cool and deep set of problems, and it's way more fun than learning how to build compilers. And now I have to go apologize to all my compiler friends, but they know it's true. Interesting question is sort of, what is the state of the art in computer vision now? What are things that are people doing with computer vision? How might that compare a little bit to the way humans do vision? Here's a simple example of stuff that, in fact, used to be sort of considered to be difficult, but is actually now pretty standard. So let's talk about simple optical character recognition. So here's an example from some license plate readers. And license plates are somewhat easier because there's a fixed font. In fact, not that long ago, doing OCR was considered very hard. Today, if you have a scanner, or if you have Adobe Acrobat, it comes with OCR built in because that's how ubiquitous and sort of easy it is. A little more challenging, many of you may have started using automated teller machines where you can deposit bank checks with handwritten numbers that are the amount. And also, for quite a while, the post office has been recognizing the zip codes using machines, again, on handwritten envelopes. So that's an example of computer vision extracting the meaning. What are the numbers that are there? Another thing that's very common these days is face detection. Just about any digital camera that you buy today, you pick it up, usually the default setting, it will find the faces. So here's an example. One of the cool things, by the way, is a bunch of lectures in the future, we'll talk about the technology that basically does exactly this. So the next time, so when we get to those and you pick up a camera and it finds the faces, you'll say, oh, I know how they're doing that. But actually now cameras can do more. I think the one on the left, I think, is from the web from Fiji, that if you take a picture of somebody and they blink, you know, and that can be really annoying, it'll tell you they blinked. Maybe even more interestingly, Sony has something called the smile shutter, which will watch for people, and you sort of press it and say, take a picture now, but actually it waits until it sees the person smile. And even further these days, there are cameras that will recognize who you are. So this is a screen taken from a shot where it does camera-based login. So it knows about a bunch of different people. You walk up to the computer, you say, yo, computer, it's me. Actually, you don't have to say anything. And the computer says it's you, and it logs you in. And so that's face recognition. We're going to talk also a little bit about face recognition, although the face detection stuff, that technology is one that will be sort of more fundamental to the class. In sort of a related way, there's a lot of technology these days involving object recognition. So there is this company, Evolution Robotics, that had developed this thing called Lane Hawk, which basically prevented some of you, none of you, from putting stuff on the bottom of a basket and then wheeling it out and forgetting to mention to the cashier that it was there. This is actually a huge problem. And this system, you can see the camera here, right? See, that's a camera down here looking at this. I wonder if we're going to have to, like, erase that that's a beer. Yeah, see, now nobody can see. Okay, you can't tell what that is. Okay, and it can detect what that is, which is not only pretty cool, but if you go on their website, they'll tell you that 5 years later, that product was bought by a different company, so there's money to be made in computer vision. Go do a really cool startup. Object recognition used to require a lot of computing power. The computing power has gotten smaller, and it allows us to now operate in smaller packages. So there's this whole area of augmented reality and object recognition by mobile devices. So here's a system of where you're showing it a picture of this statue. It recognizes who this is and what the monument is. And here's an old picture from Nokia where it could actually go off to the web, pull out information, and display it to you. So for a while, we were talking about doing this on smartphones. Now, it sits on your face. This is Professor Thad Starner, Georgia Tech professor as well. He was instrumental in the development of Google Glass. And one of the things that Glass does is you've got a camera looking out at what you're seeing and can, through the same object recognition methods, can give you information about what you're looking at. And this is also part of computer vision. There's an area of computer vision people know a little bit less about. It's used a lot in special effects. Everything from capturing the shape of somebody, so you take the scan of somebody's face, whether it's laser or otherwise, you build models, and then you can make lots of these people. And you can light them from different sides and different directions because you have a full 3D model. Likewise, motion capture. So if you saw Pirates of the Caribbean, the one with the guy with all the weird things on his face, and of course, that's all CGI. But the question is, how do they know exactly where to put his face and everything? Well, there are these markers that are being worn, that are being tracked by these cameras, and they have to figure out the three-dimensional geometry, and that's also a form of computer vision. Another area that's become big, this is a shot from Google Earth. Actually, this is from Microsoft's Virtual Earth. Google Earth is yet another version of it, where basically they can take imagery, so here's imagery, aerial imagery, but also they can use that to figure out the models of the buildings, put those three-dimensional models in there, and then you can fly around them however you want. So that's a structure for motion method of using lots of images, a sequence, to recover the three-dimensional structure. We'll talk only a little bit about that. We'll focus mostly on a couple of images. Another area that's really blossomed lately is the use of computer vision for automotive. This is a web picture taken from Mobileye, which is a company out of Israel. And they've developed all sorts of technologies that use computer vision that are relevant to automobiles. Everything from automatically recognizing signs to here, it's a little hard to see red outline. The system is automatically identifying where the pedestrians are. They have a system that alerts you if pedestrians getting close and you seem to be going too fast. You can also build systems that either brake or slow down or whatever. But the idea is that computer vision has really gotten into smart cars. And in fact, smart cars are here. So this car, some of you know, that's Stanley. Stanley was the Stanford, that's a little red S there, entry into the Urban Grand Challenge run by DARPA. And it was started by, Stanley was run by this guy, what's his name? Oh yeah, Thrun, something, I don't know, Sebastian. He's the guy who also started Udacity. He's sort of a way underachieving, no ambition kind of guy. They won that, and then Sebastian, because he's just out there, convinced Google to get involved in making the automobile process, the self-driving car, which most of you have heard about. Here's a picture of it out on the highway. And the real mark that these things are here today is states now have started passing legislation that helps detail, well, who's at fault if an accident happens on a particular road and it's a self-driving car. So this is where technology starts to hit policy and economics, and that's when you know it's real. Another big economic place for computer vision is sports. If you watch any sort of professional sports on TV, you see them leveraging computer vision, sometimes in powerful ways, sometimes in simple ways, but are really useful. So here, this is Sports Vision's first down line for American football. I say American football because sometimes when I go to Europe and I say football, they think a ball is round. We know that footballs are not round. And what's interesting about this line here is this is the line that he has to cross to make a first down. Of course, that's not on the field. It's drawn in there. The only interesting computer vision that's going on here is you'll notice that that line does not go through him. So the system had to separate out the player from the background. Okay? And even though, by the way, kind of greenish color in there, it's able to separate the grass from the player. In fact, if you ever watch one of these games, when it's rainy and it's an outdoor field and it gets all muddy, the first down line stops working so well because the grass is now mud and it doesn't look like grass anymore and it can't tell the players and the whole thing just doesn't work so well. And you can see a computer vision failure right there. Something else that has really changed lately is the pushing of computer vision down into video games. So one of the first places to do that was the Nintendo